Today's physics drill is going to be kind of interesting. I've got all my topics here that I'm studying, and what I'm going to be doing is I'm going to use the multiple expansion, and I'm going to just make a list of subtopics and sort of like a table of contents for the multiple expansion. So, the multiple expansion, what kind of topics and subtopics do we have? Uh, well, I know we have like the monopole, dipole, uh, quadrupole, octupole, um, idea. What else do we have in this? Um, I guess there's the far field approximation, for multiple expansion. Uh, Maybe we could say charge density integrals. Uh, any other related topics with the multiple expansion? Um, Maybe it's the dipole moment. You know, I don't know. I don't know if I don't know if there's anything else. Electrostatic potential in spherical harmonics. Oh yeah, because we have to do a Legendre expansion. And then there's like symmetry selections, field versus potential, interaction energy of multipoles with external fields, forces and torques on multipoles. Yeah, that makes sense. Multiple expansion of vector fields. So, let's see if we can repeat this and try to get some more topics. Some of the more important ones. Like he was saying, it was like the Legendre uh, polynomials. Then there was I like the idea of force and torque on the on the on each pole. Um, what else was there again? I'm just trying to sort of remember all these topics, put them into a list, the most important ones. Mm, I know the list is here, but I'm trying not to look. I like how he was talking about symmetries. Um, and it's really hard to remember these things. Oh yeah. There was the field versus the potential. Like I think he's starting with the E field versus potential. Um, and what about the boundary conditions? We'll have to like see about that. I think that's kind of most of what we want to think about for the multipole. Like, remember that there was still the far field approximation. There was always the monopole, dipole, quadrupole, and octupole, and there was also the the other two that we were talking about. What were they? Um, Dipole moment, possibly, and I can't remember. Arch density integrals. So let's just see whether, okay, so mainly these things, not the boundary conditions. So that's kind of cool. Okay, so that was the first topic. Okay, let's go to the next topic. Next random topic. Separation of variables. Whew, okay, so for separation of variables, we have probably it was probably it's a way to solve the Laplace equation. Um, uh, we're going to need um, I guess we have radial, uh, polar, azimuth. Um, Probably has to do with simple harmonic motion. Might have to do with Cauchy-Euler. Might have to do with Legendre polynomials, possibly. Separation of variables. Anything else? Interesting. Complete coordinate systems. Angular equation. Yeah, that's kind of what I meant. The angular equation. Bessel functions. Eigenvalue problems. Series expansion. So, separation of variables. We want to know coordinates, the angular equation, spherical harmonics, the Bessel functions. And then he says that we shouldn't be thinking about simple harmonic motion. Okay, let's try it again. So this is for separation. So we have the Laplace equation. We have radial, polar azimuthal. We have Cartesian, cylindrical, and spherical, which leads us to angular, well, no, spherical harmonics, leads us to Bessel functions, uh, leads to series expansion. And was there anything else in this? You said not the simple harmonic motion and not the, I think we needed Legendre probably in here. Alright, so I guess that one was pretty good. And we'll do one more random topic. Electric displacement. Okay, so for displacement, Um, well, I know we probably need the electric field, polarization. I think we need the dielectric, uh, permittivity. Um, what else goes with the displacement? Hmm, maybe Maxwell boundaries? Okay, let's try that. Needs one distinction. Missing coordinate field, displacement field. Well, oh yeah, the free and bound charges. Like we need free charges for the displacement, and then bound charge densities. It's more about the free charges for the displacement rather than the bound. Gauss's law. That's right, Gauss's law for the displacement field, and yeah, energy density is correct. Okay, so let's see if I can remember all this. Um, I mean, okay, the list is in front of me, but I'm going to try to do it without looking at the list. So we have, so first of all, the displacement field. We need the electric field. We need polarization. We need dielectric. We need permittivity. We need Maxwell boundary. We need the things that are free charge, uh, possibly the bound charge, um, energy density. Um, that was one last thing, right? Gauss's law for dielectrics. I think that's probably good. All right. So yeah, so this was the chapters drill, where you just kind of get one of these main topics and then try to brainstorm a list of subtopics, and then just maybe, get some, look at an official source and expand on that list. So that way it's a little bit more complete. This is just kind of the list that I was working with here. All right, cool. Thanks so much for watching. Y'all have a good night.